So, good morning, everyone. Thanks for joining us today. For this session, we're going to be predominantly talking about streaming at scale and focusing really on Amazon CloudFront to do that delivery. So my name's Jamie Mullen. I'm a Specialist Solutions Architect here at AWS, and I'm joined by my colleague John Countman, who is also another Specialist Solutions Architect, and with Jess Palmer, who is from NET307 to talk about what scale really means to them. So we're going to be thinking about, those large-scale events, those critical events that just must be delivered without any issues, and also those events with many, many viewers globally. But it's easy, right? You have a contribution feed, you do some processing on it, and it just goes to a viewer. That's it. What else do you really need? Well, it's a little bit more complicated than that. And we're going to look at, some of those design decisions that kind of help you influence that delivery. But scale can mean different things to different customers. For example, it could be millions of concurrent viewers, or it could be billions of minutes consumed. But no matter the scale, we frequently get asked by customers like, how do I monitor my distribution? How do I protect my content at the edge? How do I scale to that global audience with that high uptime? And finally, can I monetize that live content? You might be wondering, what architectural decisions do I need to make sure an event is successful? Glad to say you're in the right session this morning. But what happens if we get our job wrong as video architects or software solutions architects and video engineers? Well, viewers might get pixelation, degraded viewer experience, or arguably, it's my personal or most frustrating experience is that spinning buffer wheel. So we're going to be focused predominantly on delivering content through Amazon CloudFront today. If you don't know, CloudFront is our content delivery network, or CDN. CloudFront is a large global network with over 750 edge locations. All the edge locations are connected over a redundant and private backbone back to AWS regions. And CloudFront can be used to accelerate applications of all types, whether that's static assets like video files, image files, CSS, JavaScript, and they can be cached in edge locations and delivered really closer to those end users. CloudFront can also be used for dynamic traffic requests too. So the talk is going to kind of revolve around this steel thread architecture today, and we're going to look at different design decisions throughout the workflow. Advanced warning to all the video folk in the audience. We're going to start downstream this time. So first off, we're going to look at delivery. Some OTT providers deliver these streams for a cost, whether that's subscription or pay-per-view. So you naturally care about security, protecting your content. And next, we're going to look at encode origination. So for big events, or big sporting events in particular, this is really, really critical and important. You want to design your workflow to ensure the event is delivered successfully. And then finally, we're going to look at ingest. Simply put, if you have no feed, you have no event, right? So we'll explore different ways to make ingest more reliable. But the first thing we're going to kick off with is monitoring and ask that question, how do we know we're actually delivering that event successfully?
Okay, thanks, Jamie. I'm a solutions architect with AWS, and we want to look at how can we gauge whether our live event was successful. As you can see here, there's a lot of data available to us from our platform. Things like exit errors, video start failures, rebuffering. A lot of this stuff either comes from the client itself, the video player, or it's coming from CloudFront. So this might be presented as logs, it might be beacons. It's coming from a lot of different directions. We have a lot of data, which is good, but it's also bad. We have a lot of data. How do we deal with it all? So we're going to look into some features on CloudFront and some other AWS services to see how that we can actually make sense of everything here. So first off, every event needs good data. We need a dashboard. We need real-time access to logs, and we need to be able to analyze the event after the fact. So first off, with metrics, CloudFront actually uses CloudWatch to deliver metrics. So I like to use CloudWatch dashboards kind of compare it to an actual dashboard like on my car. When we go camping, we actually pull a trailer, and I'm constantly looking at two gauges on my dashboard. I'm looking at the fuel level because I'm getting like 5 miles per gallon on my car, and I'm also looking at the transmission temperature. So if there's an issue, because I don't normally pull a camper every day, I know exactly what to look at. I know if it gets too hot, I don't need to put gas in the car. It's actually the transmission I need to pull over. So the same is true for a streaming event. Most of these only last a few hours. In the case of like a sports event, we need to know right away whether we have a problem with an origin, whether it's CloudFront, or if you're using something like DRM or advertising, whether there's a problem with that affecting our stream. So dashboards are the first line of defense, so we know where to look, where to dive deeper. So speaking of diving deeper, CloudFront, it supports real-time access logs, and as you can see here, it actually uses Amazon Kinesis to deliver this. So delivering real-time logs for millions of viewers is extremely difficult. Kinesis is designed exactly for this. So when you configure real-time logs in CloudFront, it's going to ask for a Kinesis endpoint, and the nice thing about Kinesis is you can have multiple consumers pulling that data in parallel. So we can have real-time dashboards, we can have observability platforms, analytics platforms. We can also share this data in real time with partners, whether they're looking at viewership in real time or if they're looking at advertising data and they need that information in real time. So then with this real time data, we can see issues before they become a big problem and react to it, and we can adjust our platform in real time as needed to handle these largest events. Then lastly, access logs. These are stored in batches on S3. As you can see here, the delay is usually in the minutes. The nice thing about S3 is we can tie Athena into it, so we can query all these logs using standard SQL, and we can set life cycles on the S3 bucket. So we can have events from weeks or even years ago stored in archival, so we can compare this previous event to one that we did maybe a week or a month ago and see how we've improved and find out lessons learned. We can do some troubleshooting after the fact, and we can pull reporting easily using Athena. And then lastly, console reports. This is in the CloudFront console and is useful for just figuring out trends, viewership, cache fill ratio between events, and monthly reports. So that's always available as well. Okay. Next, I spoke a lot about CloudFront and its logs, but typically CloudFront only has access to things that are in the HTTP header or geo information, such as user agent, the client's IP address, maybe the geo region, the ASN, cache status. And this has always been logged, whether it's in real-time logs or in the S3 logs. But I mentioned earlier about the client. The client has a lot of really valuable information, such as like the throughput, the client being the player, like dash.js or hls.js. It's making decisions about which video bitrate to pull based on what it knows your home internet bandwidth is. And having that kind of information along with session ID and content ID is extremely valuable for figuring out what's going on. But in the past, this information was only available using like SDKs from third parties, and it was sending it using beacons to some other platform. So you had CloudFront or CDN logs in one bucket, then you had all the player information in another bucket, and really no way to tie the two together. And trust me, it's extremely difficult to do that. It can be done, but it's not easy. But what if there were a way to combine all this client information, such as the bit rate being used, the session ID, which rendition, whether it's HD or standard definition content, and combine that with all the information that CloudFront knows about, such as HTTP headers, user agent, IP address. And that's exactly what CMCD, Common Media Client Data, attempts to solve. It's actually a standard now that was created by CTA Wave, which has created a lot of other standards that Jamie's going to talk about later that pretty much all CDNs adhere to and the players know about. So using CMCD, all this information is kept in the same log line. So all this content ID, session ID is transmitted as query strings or headers to the CDN. And since it's standardized, we know what to do with it already. And a lot of partners that you might be using for a monitoring platform already know how to deal with CMCD. So CloudFront has supported CMCD for quite a while. if you look here on the left, this is a real-time log configuration. As you can see here, we have additional fields that are standard CMCD fields. They're all prefixed with CMCD, and you can just choose some of them or all of them, depending on what your client's sending. And all this information will be added to the real-time logs that we're sending through to Kinesis. And again, a lot of partners already support this on their logging platforms. And we actually have a reference sample that already knows how to deal with this additional information in the log lines, and it has a real-time dashboard that it actually refreshes in real time based on all this data to show exactly what's happening with the client and with the CDN. So you can scan the QR code here, or just search for the video observability with CMCD and CloudFront, and try it out on your own distribution, being a reference sample that's free to use, and you can edit it at will. It's open source. Excuse me. So it is easy. CMCD is easy. Again, you saw it on the real-time logs in CloudFront. It's just adding those additional fields and having a consumer, a dashboard that knows how to access it. This is an example on some of the players you might be using today. These are two popular open source players, HLS.js and Dash.js. And as you can see here, configuring CMCD is just a matter of adding a few more key value pairs when you instantiate your player. In the case of HLS.js, which is one I'm very familiar with, it's just a CMCD structure. But notice specifically on the left, we have a session ID now. That's actually a common or standard CMCD field, which is extremely useful. If you are using CMCD and not using session ID today, highly suggest you do it. That's usually pulled from like your content management system for that particular user when they start a session. When you include this session ID in a field, you actually can find all the logs that are tied to a specific user. So you can see individual users' journey from starting to play back your stream till end, how many times they switched bit rates, rebuffered, stalled, all that. So you can figure out individual user journeys, and then and use the same information to find other users' journeys as well, based on session ID, which wasn't possible before, since the client information and the CDN information were stored in separate locations. So it makes it super easy. Okay, so now this is security requirements. We talked about logging. We've added visibility to our CloudFront distribution. We want to make sure all of our users, our valid users, are receiving the best possible experience. But we don't want our invalid users that are trying to steal our streams, take down our, steal our content or take down our streams. We really want to stop them from receiving our content and harming the experience that other users are experiencing. So what do these users look like? Well, ideally, in a perfect world, you'd have your origin server behind CloudFront. You'd have CloudFront delivering a standard URL, in this case it's HLS and index.m3u8, and all of your paid or subscribed users would pull the content. That's not the case, as we all know. We see users that are trying to restream the content. So they're a paid, valid user coming from maybe a particular IP address, pulling our content and then restreaming it to their users who are probably paying them. Obviously, we don't want that. And then invalid regions. Not only have we not really designed our infrastructure to maybe operate in a different country for scalability purposes, when we have viewers from invalid regions, they're messing up our stats. So they might be having a bad experience, and it's going to mess up our analysis of how whether our event was a success or not. If we see viewers coming from outside of the country with high latency numbers, that's going to affect all of our reporting. And then lastly, Jess is going to talk about it in a little bit, with rights holders, there might be even legal consequences of delivering content outside of your country, where your contract states that you can only deliver in a certain region. You only have rights to deliver in maybe a specific state, in the case of sporting events, or maybe a specific country. I know in the past, dealing with some customers when the Olympics are involved, the contract for theirs is extremely specific when it comes to regions and the security required to deliver that content. So again, rights holders are very important as well. And then lastly, unpaid users that have found their way around any CloudFront restrictions and are able to go directly to their origin. So obviously we don't want that, but also if they're able to go directly to their origin, it's going to affect the experience of everybody, because the origin should be protected behind CloudFront, where CloudFront serves 99+% of the traffic from its cache, so the origin server should never be delivering content directly. Okay, so what tools do we have available to us? So first of all, my son, he's 7, he's actually been home from school recently on vacation for break, and he tends to find ways to stream YouTube when he's not supposed to. So I've tried the firewall rules on my home internet, and eventually ended up just locking the remotes in the office, and that works. So that's the tools I have, but obviously on CloudFront we don't have physical locking keys, but we do have some ways to restrict traffic. So first off, for anybody that's been in the CloudFront console, you've probably noticed the geo restrictions built in. So that's just built into the distribution in the console or through the API if you're using that. So this is a way to quickly allow or disallow specific regions. So if I'm delivering content that's only allowed to be delivered in the United States, for instance, I can go into CloudFront and quickly add geo restrictions to only allow the US, or I could block specific countries within there. But the next layer we can add on top of that, the next tool in our toolkit chain is AWS Web Application Firewall, WAF. So in this case, we can inspect anything coming in, whether it's headers, IP addresses, against a list. And we also have lists that you can subscribe to. So we have some managed lists. So we are able to allow specific regions with geo restrictions, but what about users who are using maybe VPNs or proxies to access our stream? Using WAF, we can actually subscribe to lists of known VPN endpoints, known proxy endpoints, or in the case of the restreamer, we found there that their IP address, in the case of the example, was 1234. During the event, we can actually add that IP address to our own managed list to block that user that's a restreamer. So WAF is really useful for before, during, and after event. So if you notice something specific, you can add rules after the fact for your next event. Or in the case of the restreamer, you can actually modify it during the event. And then lastly, for anything above and beyond geo restrictions and WAF, we have functions. So CloudFront functions run as JavaScript actually on the edge server. They're extremely low latency and high performant. And you're able to analyze the requests and the responses coming from CloudFront or to and from the origin, and we've added key value stores as well. So you're able to add data to the key value store using the API and query that on edge functions. So we're going to go into detail about what this can be used for when it comes to security in a minute. So how do we secure our origin? So as we all know, CloudFront's origin agnostic, so the origin could be anywhere really. So first off, if our origin is on-prem, it's most likely on a public subnet. So we obviously don't want users to access that directly, so that again, it affects the experience for everybody. So the first thing we can do is when you configure your origin in CloudFront, you can leverage HTTP headers. That's in the origin level. You can send a secret header to the origin in which the origin can validate that this is actually in fact coming from CloudFront. And then we also publish a list of known IP addresses of CloudFront edge servers that you can add to your firewall on-prem or on the origin itself to allow only CloudFront to access it. And then second, if you're using something like an application load balancer or network load balancer, maybe EC2 instances behind those for your origin, CloudFront now can leverage VPC origins. I don't know if everybody's aware of that. And recently we've even introduced cross-account VPC origins. So if you're using multiple accounts, CloudFront can access these origins on a VPC from other accounts, whether they're your accounts or even partners' accounts, which is huge because if your origin is not even on a public subnet, it can't be accessed in the first place. And then lastly, for some of our managed services delivering media, a lot of you use S3 for live and on-demand media delivery as well as elemental media package. These can use origin access control. So those are rule sets that specifically allow only CloudFront to access those content using signed URLs. So I mentioned functions to basically expand upon security above and beyond WAF and geo restrictions. We see a lot of customers use tokenization within functions to further secure content. So a token, it's actually typically we see JWT used, but there's quite a few formats out there. And using functions, we're flexible. You can basically implement any sort of function mechanism that you'd like, whether it's JWT or some custom function or some custom token that you use across other CDNs. So inside the token, it basically describes who you are, what you're able to watch, like a content ID, and it would have a time limit. So in the case of JWT, it's very easy to set a lifetime that this token is only valid for an hour, 2 hours, a full day. And then it also provides instructions on where and what you can watch. So ideally, a user with a valid token, they're sending all this header information and IP address information to CloudFront. We're able to look up their geo information using geo headers that are configured in CloudFront, and the token contains all this information that they're able to watch from a specific, maybe US state. They're tied to this particular IP address or user agent. And the function is going to validate all this against the token and what CloudFront knows about the user. And if everything matches up, the token wasn't modified in transit from the user, and the token hasn't expired, then we just return a 200 OK within the function. And then we have users with invalid tokens. Maybe they tried to modify the token and create their own token, and it's invalid because it wasn't signed correctly, or they're coming from an invalid location. They maybe traveled with a valid token. We signed it for their home use and they're on their cellular network, and they didn't receive a new token. We'll actually return back or manufacture a 401 unauthorized response from the function itself and immediately deny that user before they even hit CloudFront in the origin server. And then lastly, we have a user here with a shared token. Again, all these examples are using JWT, which is really common, which is easily implemented in functions. This user has a shared token, so they received a valid token from the first user, and they're trying to reuse it, and they might be living in the same neighborhood and using the same device, so it happens to be valid for some reason. But we noticed that this user, this token is being used multiple times and is not valid. We can actually add this token value into the key value store. So that's before I said a good use case for key value stores and functions is token revocation. So you can insert this token into a key value store when you notice something wrong with it, it's being used too many times, and then you can have the function return a 403 forbidden if that token's in that key value store. So again, this is a common use case that we see for tokenization, JWT tokens. But actually, we've recently, right before reInvent, released CBOR token support, which is needed by the Common Access tokens, which again was created by CTA Wave. So instead of having to figure out how to write a full token authentication workflow in functions, you can just tie directly into CBOR, which is supported as a module in functions, and the code is extremely minimal. I was using it earlier, and it was just a few lines. So that's natively supported now. And again, common access tokens seems to be where the industry is headed because it has been standardized now. So we do have guidance for secure media delivery at the edge on AWS. So this takes all the work we've done on functions and does it for you. So you can simply deploy this onto your CloudFront distribution, and we're going to deploy all the functions supporting JWT token support. And we have a step function available that's also deployed that can automatically revocate tokens that are being used incorrectly, either multiple times or from invalid users. And we've even added a full playback application, sample application with video players, so you can try it out. So you can just deploy this using CloudFormation on your own distribution, and being open source, you can modify it at will. We've even included SDKs for your content management system to create tokens and sign tokens when you create playback URLs. So check it out if you haven't. And we're actually enabling support for common access tokens in this really soon. That's coming shortly. So yeah, just keep an eye on it for the updates. Okay, so I'm going to hand it back to Jamie for a talk on last mile capacity.
So large-scale events can generate significant internet traffic spikes over a really short period of time, which strain network links that connect viewers to end content. However, there might actually only be a certain amount of capacity between an internet exchange itself and an ISP or a smaller city. For example, ISPs continuously optimize their networks, but scaling capacity for like those last-minute big events is understandably challenging, right? Especially those events that you only need that capacity for that short period of time. When a network becomes saturated or congested, both packet loss and increased latencies can occur, and the result on the viewer experience is things like quality drops, rebuffering, or even those playback failures. Remember, you can lean on that monitoring approach that John spoke about earlier to try and help you identify some of these issues. But unless you own the network or the underlying network as an OTT provider, this is something that is really largely out of your control. Last year, however, we introduced embedded POPs, and they overcome this challenge by getting you closer to those end viewers, caching content directly inside an ISP network and removing some of the dependency on the network links between the viewers and the internet exchange. If you didn't see it on the POP map before, we've got over 1,140 embedded POPs across over 100 ISPs in more than 20 countries. Because that distance to end viewers is reduced further, customers that already adopted embedded POPs have seen performance improvements too. Because we're able to remove some of the network dependency, they're really great for highly cacheable content. So we're very focused on the media and entertainment space today, obviously, but you can also use them for things like, or content like game delivery and also software downloads. So as part of the onboarding of embedded POPs, we validate the workflow that you want to use them for. If it is a good fit, the distribution is enabled up by us in the back end. However, there is some additional work required on your side to make sure your client application can route to embedded POPs. The way that we recommend doing this is integrating the client routing SDK into your URL vending service. So how does this work? Well, firstly, you need to do that integration of that client routing SDK into your URL vending service. The QR code on the bottom right is actually the link to that SDK in GitHub, if you're interested in having a look at that. So when the client application requests a URL from that vending service, the client IP is encoded into the URL, and it's annotated as CR label in this diagram. The client then performs a DNS lookup, and Route 53 and CloudFront is able to decode that client IP from that CR label itself. Then CloudFront returns the best POP based on that client IP, whether that's an embedded POP if appropriate, or a traditional POP. The client can then start fetching content from CloudFront. So in summary, embedded POPs deliver cached content directly from ISP networks, improving performance and overcoming those potential last mile capacity constraints that you might have. If you want to make use of embedded POPs, I really urge you to contact your account team to help you evaluate your workload to see if it's suitable. So typically, the next bottleneck that we see is the origin. Our aim really is to offload as much traffic as possible from the origin so that it has enough capacity to serve requests at scale. This is to prevent our origin from becoming overwhelmed and failing entirely. Caching helps with this, of course, and CloudFront uses tiered caching, so we have edge locations, we have regional edge caches, but you can also use something called Origin Shield to further reduce that origin load. Instead of regional edge caches hitting the origin directly, they go through Origin Shield, and this provides a better cache hit ratio, reducing demand on your origin, especially for those events, we've got a lot of scale. So we've covered capacity, we've covered reducing load and ensuring viewers can get a great experience. It's time to really think about how you design the rest of the platform to provide just that, right? To quote Werner Vogel's, everything fails all of the time. Lots of customers approach this by thinking about, how many nines you want to design for. But when you're thinking about a media world, this can also be very different if you're designing a 24/7 channel, for example, and those event-based channels. And the other important part is you've got the task of really balancing the cost and how much resilience is really enough for you. If your platform fails entirely, users will be unable to consume your content. And this might impact you in other ways, such as increased customer contact or maybe even financially too. For live events especially, there's no real second chance or try again later. That moment's just simply gone forever. Like we discussed, things can go wrong. So redundancy is really critical to keep your stream up and running so that you can deliver to your end users. In this example, in particular, we have 2 EC2s in 2 availability zones to try and help combat this. We do see customers deploy their own encoders and origins in AWS, but we do offer managed services for media workflows. They offload the challenges of managing your own customized infrastructure and gives you capabilities and features that we'll actually talk about in a little bit. These features are such as like helping you provide that best viewer experience possible to end viewers. So if you're not familiar with AWS Elemental Media Services, this is a typical workflow for an ATT stream. So we have AWS Elemental Media Connect, which is our secure and reliable transport service for live video. That's then fed into AWS Elemental Media Live, which is our cloud-based broadcast-grade video processing service. We then have AWS Elemental Media Package, and that is our just-in-time packaging and origination service, where you can implement DVR-like functionality and things like DRM. And finally, we've got Amazon CloudFront, which is our CDN, which we're predominantly focusing on today. And then viewers, depending on what they want to stream, what manifest they need, can pull different origin endpoints from Media Package. So with this, we've kind of moved from EC2 and we've gone to AWS Elemental Media Services. So we no longer have to worry about those underlying instances and get all the benefits of AWS Elemental Media Services. For example, Media Live supports cross-AZ synchronization and redundancy for failover scenarios. Customers running large events tend to implement more redundancy than just one region though. So we're going to look at what that multi-region architecture might look like. To help kind of speak this through, I'm going to look at a typical failover scenario that you might see, but looking at where manual intervention might be required. So we have the same architecture as what we had, but obviously we've got region 1 and region 2 with Media Connect, Media Live, and Media Package. We also have the addition of Elemental Live, or AWS Elemental Live, which is our on-prem encoding appliance, which in our case is doing that venue contribution encoding. So let's say something goes wrong with one of the contribution feeds going to region 1, where the viewers are currently streaming from. Well, viewers connected to that might start seeing black frames instead of the actual video content or real content. But hopefully you've got a real an eyes-on-glass operations team, and they spot this issue early on and decide that they want to do that failover to region 2 manually. But remember, there's a time delay, right, between the issue occurring, somebody spotting it, and then also proactively rectifying that situation. So the failover occurs, our viewers go to the URL vending service and say, I need a new URL, and it returns one for region 2. However, there's a few challenges here to kind of think about. Number one, predominantly, is it requires somebody manually to do this, right? And there's also a time delay in detecting it and then remediating it. But not only that, when a viewer rejoins, are they going to have to go find where they were viewing in a stream, for example? And then the timing might be misaligned between the two regions anyway. So how do you keep things in sync? How do you do these things automatically? So we're going to explore this further, but we're going to start with timecode. Timecode is time reference that's embedded in each video frame. Timecode can be really important in the media distribution world. We want to use it for synchronization in downstream components, such as the encoder and packager, to provide that frame-accurate alignment. So timecode is part of the answer, but how is it actually applied to a failover scenario? We have a feature that can help manage this, and it's called Seamless Cross-Region Failover. So we're going to start with the Elemental Live encoder on-prem, and that's going to use the same timecode source, so both regions receive an aligned contribution feed. Media Live is then configured with epoch locking and uses the embedded timecode, with that timing source being that input clock. And then CMAF ingest on the output of media package into media package, And when you combine CMAF ingest and epoch locking, it results in this regular segmentation cadence based on the epoch time. Media package can then use stateless synchronization to help predictably package the output content. So what happens if something does go wrong, such as slate input, incomplete manifest, and a missing DRM key? Well, media package actually has the ability to 404 its endpoint. And CloudFront is configured with something called origin groups, where you specify a primary and a secondary, and also a failover criteria based on a HTTP status code. When it picks up that media package has indeed 404'd one of its origin endpoints, it'll automatically send that traffic to the secondary. But what if it's not such a fundamental problem, for example? What if it's black frames, frozen frames in the source, and it's only impacting one of those contribution feeds going to one of the regions? Well, building on the previous architecture, we have a capability called Media Quality Aware Resiliency to solve this, or MQAR. So Media Live actually has the ability to also produce something called an MQCS score on each segment, and MQCS stands for Media Quality Confidence Score. And that's based on those input parameters of being black frame detection, frozen frame detection, or input source loss. And that score is out of 100. And each score is independently based on its own input. Media Package actually has the ability to use this in two locations. It's able to use it on the input to provide in-region failover, and also on its output via CMSD, or Common Media Server Data. John spoke about CMCD earlier. CMSD is also part of that CTA spec. And then finally, you continue to use origin groups on CloudFront, but instead of it being default, we use Media Quality Score being the origin selection criteria instead of default. The way it works is there's a get and a head request sent to both regions, and it basically picks the segment that's going to ultimately provide that better viewing experience to end viewers or clients. So in summary, you can leverage AWS Media Services and Amazon CloudFront with MQAR, or Media Quality Aware Resiliency, to automate your eyes on glass and minimize the duration of disruption events. We haven't got long left.
All right, thanks, Jamie. Can you hear me? Okay, good. All right, so all these measures we've taken to analyze our stream using logging and to make sure our origin and encoder are available are useless if our contribution stream into the cloud is not stable. So we need to make sure our contribution stream is reliable, just as the rest of the chain on the encoder, the origin, and CloudFront. So how do we make sure our source is just as reliable as our delivery? Well, some of the things that we require in our source are consistency. We need a reliable source. We need coverage of that source wherever our event happens to be. And we need it to be private, because usually this source coming into the cloud is our highest quality mezzanine feed. So we don't want anybody to be able to access that, as it's the, again, it's the highest quality content, and we don't want that to go into the wrong hands. So we do have a solution for that a lot of customers use, and that is Direct Connect. Direct Connect's used heavily for stream contribution. For consistency, it is a dedicated connection into a region, offering up to 100 gigabits of connectivity. So a lot of you all are probably contributing content now through some of the higher quality lossless formats like JPEG XS and using 2022-7. And if you're doing things like that, Direct Connect is extremely helpful for things like that. And also, it is reliable. You can have multiple paths into the region using Direct Connect. And coverage is in over 100 locations worldwide in 30 plus countries, so it's probably nearby or at the facilities that you're broadcasting from, like stadiums and things like that already. And again, it is private. It is a private network, and we are able to add things like media encryption on top of it, which we'll talk about in the next slide. So this is where Jamie spoke a little bit about Media Connect. So this is one of the elemental services for entry point of live media into the cloud. Whether you're using Direct Connect or internet contribution, you can use Media Connect for both of those use cases. So if you're using Direct Connect, you're probably ingesting over a VPC. If you're using internet connectivity, you can certainly use a VPN endpoint and also ingest through to Media Connect over a VPC as well. So utilizing VPC origins and VPC ingest, the whole media workflow can be private, since CloudFront supports pulling from a VPC, and we can ingest to a VPC as well. And we mentioned encryption earlier. A lot of the protocols that we support on Media Connect offer encryption, such as SRT and ZXE and RIST. SRT you actually use quite a bit, and enabling encryption on that's trivial, and pretty much every encoder out there that publishes SRT supports encryption. So whether you're using the internet or Direct Connect, encryption is an option. And especially over internet contribution, packet loss is a thing. Drop packets are a thing. Most of these protocols like SRT and ZXE and RIST and RTP-FEC support error correction and ARQ, automated repeat requests. So this is all adjustable on Media Connect and on the encoder. So if you're doing contribution over the internet, adding a little bit of latency in exchange for reliability is available in Media Connect. So you can just you can add a little bit more error correction for known spotty connections. And both of these protocols, Zixi and SRT that I mentioned, allow for failover of the stream. So you can have multiple ISPs contributing over Media Connect, and if one of them has an issue during the live event, it can automatically switch over to the other one. And then I mentioned earlier about metrics. They're super important. The dashboard that we create before the event, it has CloudFront on there, so we know if there's an issue with CloudFront. Most likely it contains metrics from the origin server to know how the origin's performing, and if we're using DRM or ad insertion, those metrics are also available. But we can also add ingest metrics to the dashboard as well for AR key recovered, drop packets. So we have a quick view on whether our ingest is having issues, whether it's CloudFront or the origin. For SRT, which is one of the most common protocols for ingest over the internet, these are the recommended metrics that we see being used for dashboards for Media Connect. So these are the ones that, for the largest live events that customers are actually monitoring really closely for ingest quality. So next, Jess Palmer is going to come over. She's from New England Sports Network, home of the Red Sox, and she's going to speak a little bit about her platform.
Thank you. So NESN is not the largest RSN, but we are actually the first RSN to offer a direct-to-consumer live streaming app in 2022. As a regional sports network, NESN has a small digital team, mostly me and my boss, serving a growing user base. Armed with basic streaming knowledge, we were able to easily learn and manage the stream flow through AWS cloud services. RSNs like NESN have unique streaming challenges. They must deliver high-quality, low-latency live and on-demand sports content, enforce regional broadcasting rights, and handle unpredictable traffic spikes, all while maintaining strong security and compliance. Additionally, unlike many national distributors who receive SRT feeds and then retransmit those, at NESN we control every step of the broadcast. First, the game is captured by cameras which are connected to our mobile production unit, otherwise known as the truck. It's an actual truck with the production equipment inside it. We have 4K cameras and HD cameras at Fenway Park for the Red Sox and at TD Garden for the Bruins. For away games, we have our own HD cameras that travel with the teams. The feed is then relayed over the internet from the truck or from the opponent's stadiums to master control at our Boston office. These feeds are shared directly with our linear distributors for fans still watching sports the old-fashioned way through their cable subscriptions. And additionally, the SRT feed is routed directly to AWS through AWS hardware encoders. About 50% of the Red Sox and Bruins season's games are home games, which we offer in HD and 4K. AWS makes it easy for us to manage the availability of our 4K stream using an AWS elemental encoder via Media Live for transcoding and streaming management. We installed Media Live Anywhere on our AWS elemental encoder with John's help, so that we could administer the feed through Media Live the same way we manage our HD and UHD links in the Media Live dashboard. From the 4K source, we configured a Media Live output group that contains 4K, 2K, 1080p and 720p video outputs, as well as stereo and surround audio outputs and closed caption outputs. We kept the audio and video tracks separate because we found that muxing resulted in issues with some of the OTT players. We used a media package v2 channel group to create Dash and HLS origin endpoints, again for compatibility on different systems. And those origins are then used for CloudFront distributions. A major advantage to using CloudFront is that it automatically scales to accommodate traffic variations. So for example, if the Sox are playing the Yankees, we don't have to worry about edge capacity. CloudFront takes care of that for us. We also occasionally get third-party feeds or one-off direct feeds, like batting practice directly from Fenway Park or morning skate from Bruins practice arena, that we offer as digital exclusives. And we have an HD link that we use for those one-off events. We use the same basic flow for those events. The live or third-party feed is rolled out through the HD link, and the HD feed is transcoded into lower output tiers to accommodate CTV and mobile devices. Then it's the same media live to media package to CloudFront flow. Additionally, CloudFront logs across all services provide metrics and alarms that help detect performance issues early, maintain stream quality, and ensure smooth delivery. Having these logs easily accessible and queryable using log insights is essential to a lean digital team like ours. In summary, CloudFront empowers NESN to deliver reliable, high-quality streams for every fan, scale seamlessly during live sports peaks, protect media rights and maintain regulatory compliance, and gain real-time insights into audience behavior and performance.
All right, thanks, Jess. It's really cool. I always love everything that you're doing over there. Jess spoke a little bit about Media Tailor. It was on her diagram earlier when she gave a demonstration. Media Tailor is a managed service under the Elemental umbrella that does ad replacement and ad insertion for live streams, or on-demand streams, actually. This workflow here, again, it uses Media Tailor, but a lot of the other ad insertion platforms work in a similar manner. When you're trying to monetize your streams, it adds a whole new set of challenges. In effect, this is called dynamic ad insertion, and just by the name, you add a dynamic element into it. Every single manifest for end users are personalized because they have ads destined for that end user, whether you're using linear ads or whether you're using some of the newer formats like squeeze back or pause ads. So before, we've always talked about scaling and CloudFront scaling the origin. When we talk about ad insertion, the origin becomes that much more important because every single request from the end user, whether you have 1,000 or 1,000,000 users, are going directly to the origin, and the origin is modifying the manifest in real time. So it's really important that your origin can scale with your viewers appropriately. When you configure CloudFront for advertising, you're going to have a couple more behaviors being configured. For your manifests, you're no longer caching that. You're sending them directly to the origin server, which is then modifying every single manifest going to the end user. Then the Media Tailor, in this case, is going to make a call to an advertiser upstream, whether it's SpringServe, FreeWheel, any of those ad platforms. And those must scale as well because every single request is going to be a unique request to an ad server. So it's really important when we add dynamic ad insertion into a platform that we look into that as an origin, as well as DRM platforms as well. That they're typically not behind CloudFront. Media Tailor has actually recently added some features to help with the ad platform, because if everybody's going to an ad break at the same time and we're hitting 1 million viewers to an ad platform all at once, the ad platform, whoever it might be, can't handle that. So Media Tailor actually has the ability to prefetch ads before an ad break and stagger requests to an ad server. So these are some of the really important considerations when you're adding monetization to your live stream. Again, whether it's linear ad replacement, overlays, squeeze backs, or any of the newer formats. There's a lot more considerations that you have to look over, specifically with the origin server being the ad insertion provider. So I want to hand it back over to Jamie for the summary, and yeah, here you go.
Cheers. Thank you.
Cheers.
So, to wrap things up, we wanted to aim this talk about, thinking of ways that you can, or to help you deliver those events successfully and at scale. We want you to remember these key things when you start planning for your next large-scale event. So firstly, observability is critical, right? Whether that's dashboards, data collection through real-time logs and Kinesis, but think about how you could use other data points such as CMCD and CMSD to also help you with your observability. Architecture actually architecture design can actually also go beyond just the encode and the origination, right? We covered AWS Element Media Services, but also remember how to leverage other infrastructure to help you absorb some of that traffic, such as embedded POPs and Origin Shield. Security is also a really layered approach. There's not really one mechanism that fits all. So think about your end-to-end security strategy, covering tokenization, IP blocking, geo blocking, and using mechanisms like CloudFront functions and AWS WAF. And then finally, monetization can be just more than a subscription payment, right? You can use server-side ad insertion to help you monetize your content using services such as Media Tailor. So if you want to learn about or continue reading on some of these topics that we discussed today, or want to deploy the samples, here are the links to them. And finally, if you're interested in leveling up your skills on network and content delivery, I thoroughly recommend you check out Skill Builder. So that concludes our session today. Thanks for joining us. I hope you found it useful to kind of think about the next things you need to look out for those large-scale events. Just a quick reminder, please go to the reInvent app to submit your feedback on the session today so that we can help improve it. But yeah, we'll be hovering around if you've got any questions for what we spoke about today. But enjoy the rest of your time here at reInvent.